Okay, so question 5. We have a cross-section of a small zinc air button cell. It's used in hearing aids. So we have an anode, which is powdered zinc in a gel containing potassium hydroxide. And then we have our air diffusion layer. So we have a carbon cathode with an air access hole. So access for that atmospheric oxygen. The zinc acts as the anode. It is in the form of a powder dispersed in a gel. So a jelly-like substance. It also contains potassium hydroxide. So we'll be writing our hydroxide ions as aqueous, because it's in this kind of liquidy jelly-like substance. The cathode consists of a carbon disc. Oxygen enters the cell via a porous Teflon membrane. This membrane also prevents any chemicals from leaking out. Following reaction takes place as the cell discharges. Write a balanced path equation for the reaction occurring at the anode. So, at the anode, well, we've already been told that zinc's at the anode, so we know it's going to be this and this. I am going to use text here because I think it might be more simple. I'm going to say, cool, so I've got my zinc solid, and I'm going to produce my zinc hydroxide solid. Now, we've got zinc here, we've got zinc here, but where's my hydroxide coming from? Well, it's just coming from my potassium hydroxide. So, I've got my zinc plus, I've got, ooh, cool, I can bring this in a little bit then. I've got my zinc plus, I've got my hydroxide ions, which are aqueous. Now, looking at this, it's at the anode. That means it's going to be oxidation. So I'm going to need some electrons in there, and also I need to make sure it's balanced. So, first of all, I'm going to say, hey, is this hydroxide here balanced? Well, no, I've got two of them. So I need two here. So I've got my zinc, I've got my two hydroxyl ions, and I've got my zinc hydroxide. Need my electrons. It's oxidation, it's lost, so electrons are going to be on this side of the arrow because they're lost, and in the reaction, therefore, the electrons are the products. And I've got two negative charges over here, so I'm going to say 2 electrons. And that is my half equation for the reaction occurring at the anode. What about, suggest one role of potassium hydroxide in this cell? Okay, so there's a number of ones. First of all, you can just say potassium hydroxide. Well, it's electrolyte, isn't it? Electrolyte. Spell it better than me, please. Or I could say allows for again, spell better than me, electrolytic conduction between the electrodes. Or I could say, well, I could think more about what do electrolytes do in two half cells or in a salt bridge. And if we think of it like that, we can say, well, also, potassium hydroxide provides K plus ions to move towards the cathode, and OH to move towards the anode and balance electrical charge, or balance the charges, so electric charge around the electrode. Just how anions and cations migrate from the salt bridge. It still happens in batteries. Or we also talk about that salt bridge between two half cells as the internal circuit. So we can say that KOH provides the internal circuit as compared to the external, which is in a galvanic cell. Oh god, I put a U, that was wrong. Terrible typing. Provides internal circuit, external circuit being that wire that links to electrodes, or simply for a battery, whatever is connected up to take that electricity away. from the spontaneous discharging reaction. So these are all good options. As for C, you just completely ignore that because it's not relevant to what we're doing right now. And let's move on to D. Okay, so we're just going to ignore my previous typing there. Hydrogen-oxygen fuel cell can operate with an alkaline electrolyte such as potassium hydroxide. In this cell, the reaction at the cathode is same as that in the zinc air cell. A porous carbon cathode is used. Write the half equation for this reaction that occurs at the anode in a hydrogen-oxygen cell with an alkaline electrolyte. So we know what happens in the hydrogen-oxygen cell. We get hydrogen and oxygen gas and we produce water. We need to say what happens at the anode. Well, we are going to go from hydrogen gas, so we're going to go from H2 gas, and we are going to produce, as an end product, H2O. Nope, that's not an O, that's an O. So, hydrogen, when it's H2, it's 0. Hydrogen in water is going to be positive. So that's going to be that loss of electrons. It's what's going to be occurring at the cathode. So I'll put my liquid in. But what else am I going to have here so I can get hydrogen into water? Well, we know that it's going to be an alkaline electrolyte. Oh, I can't select that. Okay, well, it's going to be an alkaline electrolyte. So I've got my hydrogen gas plus a hydroxyl ion, aqueous. Is this all balanced? No, I've got 2 hydrogen here on my reactant side, 2 here, but then I've got another 3rd hydrogen on my reactant side plus my oxygen. So nice and simple, I just need 2 lots of water and then 2 lots of hydroxyl ions, and then I've got 2 oxygen, 4 hydrogen, 4 hydrogen, and that's my full balanced equation. I also need to be thinking then, where am I putting my electrons? Anode is oxidation, oxidation is loss, electrons are going to be part of the product. Okay, so that is my overall reaction.